Good morning, class. Today, I wanted to spend a little bit of time talking about the grant writing process. It's a big part of science and something that, I think that would be interesting to some of you to learn a little bit more about. If you don't really care about the grant writing process, feel free to ignore the rest of this message. I'm not going to be going over, class material necessarily, but instead giving you a sort of glimpse into the grant writing process that enables scientific research to occur. So, from my experience, I tend to write grants for private foundations. You can also establish contracts with pharmaceutical companies, these sorts of things. With a foundation, you would tend to tailor it to the specific foundation. For example, if it's the Parkinsonian Foundation, you would want to use language, associated with their mission and try to appeal to their interests. For the NSF, the National Science Foundation, they care exclusively about basic science. So, as a dopamine researcher, I tend to write about, what are the roles of dopamine release events and ethologically relevant behaviors. Now, for the grant that I'm going to talk to you about now, for the National Institutes on Health, you would want to write about, something that would benefit public health. I usually target the National Institute on Drug Abuse and Addiction, or NIDA, which is one of the many, parts or components of the National Institute on Drug Abuse. So now I'm going to share my screen and show you exactly the grant that I've been preparing or developing over the last month, or really more than a month. Let's see, where's my share? There we are. Share. So here is a folder containing all of the component parts of the grant that I just had to put in for routing. So at this point, it's being hopefully processed by the dean's office, and it will go through a lot of internal checks before they send it off to be reviewed by a panel of other scientists. I am given a roster, so I know exactly who is in the room when my grant is being reviewed. And it takes over a year to get feedback. And at that point, you have one opportunity to potentially respond. Usually they cut about 50%. And if you're in the top half or so, you may have a chance to respond to the critics or the critical comments. And usually you have to be in the upper, let's say 5% or so to secure funding. So, there are multiple component parts to here. The budget, I'm not going to show you the full budget here, but this is sort of what it looks like. You would account for, various salary elements here for multiple years. Usually we would provide some sort of money for undergraduates to come and help out with the research. Usually, I have allotted here for a research assistant that would be a full-time 12-month employee to work on the grant that would come in on starting on year two. Then you have these things called fringe benefits. This would include things like, covering insurance, benefits, these sorts of things. We would have to include travel to go to scientific conferences, like to present our data. Materials and methods, the amount that it would actually cost to conduct the experiments per year. Sometimes you would have contractors or consultants. Publication costs, it costs a lot of money to publish a scientific article in most journals, especially at a certain level. I've paid upward almost $2,000 at times to publish scientific papers, particularly if you want to make them open source so anybody can read them and they aren't restricted by library contractual agreements. Yes, in addition, the university takes what's known as indirect payments. At the University of Colorado, Denver, they take about 56%. You can see that value right here. So that would have to be paid on top of the grant for the university to pay for certain expenses associated with it. One benefit of the NIH is they pay these indirect costs on top of your award, whereas the NSF takes it out of your award. So when they take that 56%, it really, takes a good piece of the pie for the NSF grants. One benefit of the NIH. So then, there are additional elements to this as well. But first, let me go over the criteria which you are ranked. So there are 5 criteria that your grant is judged on. These are its significance. How is this going to advance public health in the case of the NIH? Innovation. How am I doing this better and in a more leading edge way than my competitors? 3, the actual approach. Is the grant good? Are the aims well controlled? The environment. I mean, how is CU Denver, for example? Is the institution able to provide facilities and resources to support the grant? And finally, me. How am I qualified to do this? So to validate myself, you prepare a bio sketch, which after the budget and the budget justification here in my folder, you can see that the bio sketches are next. I describe myself, what I do, some of my professional activities, some of my awards and honors that I've received over my career. And then you overview some of your contributions to science in paragraph form, ending with a link to your PubMed or NCBI list of publications. So in addition to the bio sketches, then you provide a summary and a narrative of your proposal. And this is not trivial. They want very brief, succinct, sort of lay summaries of what you're doing. One is more for the scientific community, and the other is more for the general public. Politicians and members of the public do read these. Peter reads them. The Congress reads them. My wife actually has had one of her projects singled out by some members of Congress. They sort of, and it even made it into the news. They were mocking the idea of giving monkeys cocaine, or getting, like, we're wasting taxpayer monies by getting monkeys high on cocaine, was sort of the comedian's blurb. But so it does need to be well justified what you're doing, and you do need to keep in the back of your mind that people are going to critique this. Right, it does need to be very clear how it will benefit everybody. Then a draft, my bibliography and references cited in my actual grant, a data sharing plan. This is a somewhat new thing, but here I wanted to show you that. Here, this is really great. I think that this really addresses, what some say is a replication crisis in science. I think some of that is a little overblown. I think it's somewhat field dependent. In some fields like the behavioral sciences or social sciences, especially, I think have been, scrutinized a lot recently for this. To that, I also think that there is a good argument that is also a little overblown. Behavior inherently has a lot of variability to it. If you assess behavior, in a college campus with college students, and then go see if the same is true in inner city Baltimore, you might not be able to replicate the exact same thing because there are socioeconomic, racial, sex, gender differences in how people are eating, differences in so many variables that could influence replication. In neuroscience, I tend to see, especially my dopamine signals, my dopamine responses seem to be pretty reliable across labs, and I use very objective operant behaviors. And I think that I have been replicated successfully, usually. There are a few, but usually I think a lot of my work has been very replicable. But anyway, to combat this perception of a replication crisis, now to get your grant reviewed, you need to highlight exactly how you're going to make all of your data available to be scrutinized by others. So here I list exactly, the kind of data I would be generating, how I'm going to store it, how I'm going to make it available to everybody, which I do in these sorts of repositories. I also make all of my data analysis programs that we develop available, and also how we will over uh, uh, be responsible for this or review it. Then we need to describe the facilities, the equipment that I will use to collect the data, the specific aims. This is really the most important part of the grant, arguably. It's one page, like a one-page summary of the grant. And this is what everybody in the reviewing room will actually read. It is sort of like the abstract of a paper. 100% of the people will read this. So if there are any problems here, people will pick up on it. The approach itself is the actual grant. These tend to be around 12 pages, depending on the grant type. And you have to describe exactly what you're going to do with specific predictions. And for the NIH, you have to use account for sex. You have to include sex as a variable. In this case, I'd be comparing male and female rats. And you have to have very specific hypotheses and predictions and this, alternative interpretations. But only about 3 people will read the full grant, and whereas everybody else will only read the specific aims. And then, in clinical grants where you're using human subjects, you have to go into great detail about how you will, protect their data. Because I work with animals, with rats, I prepare a vertebrate animal section where we talk about care, we talk about animal number, power calculations, justify why we need certain numbers, and also enrichment. Enrichment is key. You have to describe how you will provide enrichment and care for the animals and do everything ethically and safely. That is highly scrutinized, by many groups. I mean, like most certainly, uh, representatives of PETA would look at this. It is not something that is taken trivially or to take trivially. You have to have a good vertebrate animal section. You have to have good enrichment available for the animals. It cannot be, uh, you know, uh, incredibly harsh conditions. So yeah, that is essentially the grant writing process and what it entails. It is a lot of work to put one of these things together. And the odds are daunting. There are many more grants that are submitted than can be funded. Uh, but we are very fortunate in the United States that a large amount of money is dedicated to this. When I think it's easy to get too caught up in the 5% are going to be funded, or maybe 10% if you're lucky in a given budget year. But I don't know. I've traveled a lot around the world. I've interacted with scientists in a lot of different countries, and I think we would have to say that internationally, we're very fortunate in the United States to have great opportunities to submit these grants. And also, I will say, especially compared, and things can be better, but especially compared to elsewhere in the world, this is a very accessible system. In certain countries in Europe, for example, there are it's a very good old boy type network still. You really have to sort of know somebody to have a PhD mentor and then sort of be brought into the system. I think we've done a very good job, particularly over the last few years, of making science more accessible to lots of different people. And it isn't just all white men anymore. I think that the demographics, you're seeing clear shifts. There is still a ways to go here, but I do want to just emphasize that I think internationally speaking, the United States is really on a very a good trajectory here that needs to continue. It needs to grow. It needs to be better. But the grant writing process, as daunting as it might seem, is relatively accessible here versus anywhere else I've experienced to date. Yeah, anyway, that is what the grant writing process looks like. I hope you enjoyed that little overview. And if not, sorry if I bored you.